Hello everyone, this is VivianKong, and this is my project of this class. It's a nonlinear impact of temperature on the growth rate of agricultural producing values. Um, now, I'm always interested in the topic of global warming, and we hear a lot of news from Facebook, social media, right, and the news on very scary facts or very scary stuff. Um, so what I would like to do here is there are two main problems and I want to solve or I want to see on my own. Then the first problem is I want to be more objective about this problem. So that's why for the first question I want to answer is the correlation between the greenhouse gas emission and the temperature. Now, by physics, we know that the greenhouse gas absorb the heat and so keep our planet warm and warm and warm. So that's how our temperature increasing. So this is the physics behind it, like science behind it. But what I want to see is how strong they correlated to each other. So this is my first question. And then for my second question is I want to see that how the high temperature impact the growth rate of agricultural output for countries on different latitude. So now my main challenge, there are two challenges I have in this project. The first challenge is find the focus because at the beginning, I know that I want to do something with temperature and economic sectors or economic activities, but I just don't know where to look, what to look into, like where to look into it. Um, the the topic still was very broad. So I don't know like which part I should look into it. And luckily, I talked to our professor, and he gave me some direction, some advices. So that helped me to find my focus, which is just focus on the agriculture producing values, but with different latitude. So this is, I think, it is a pretty new point of view in this kind of research, because most of researchers I find and I read is they are what they are separating countries depends on their income or the GDP per capita. It is a good one. It is good because the low income countries seem suffer more, right? This is what we think. Um, but the problem for me is how do we define the developed country or developing country? I feel like for example, for China, China's economy is booming, was booming, or is booming, is growing so fast. So does China count as developing country? Or maybe does some countries we think they are developed country, now are they still developed country? So I think the concept of developed country and developing country is always changing. So that's the part I don't really. I think there's something that need to be improved. So that's why I want to talk about my problems from different latitude. Now, here are some reasons for different latitude. Um, First reason is now if you see if we're talking about low income country or high income countries, and then you can see that many low income countries are in the low latitude, like Jamaica, Haiti, Ethiopia, like those Mali. So those countries um, are around the equator. Um, which is we definitely define them as a developing country. But also it's interesting that to see many of them just in the low latitude. And the most agricultural producing countries, they are in the middle. They are like between 20 degree to 45 degree. Well, the reason behind it is, I think, is pretty straightforward. It's because their initial climate is optimal, or is the greatest for the agriculture developing. They have 4 seasons, a good amount of rain, and then the temperature just perfect for the cycle of the plants. So and then if you're looking at the between 45 degree to or higher, so those are the countries are colder, and so they're probably not agricultural producing countries. But if you're looking at their GDP or GDP per capita, most of them are pretty high. Like Ireland's pretty high, Norway, U.S., Canada, those countries, or Russia become higher and higher now. So I mean, the developing country, I'm not gonna using that, but I'm using the latitude, different locations. So it's still a similar idea, but I think that there are a little bit improvement from it. So now this is what I do for my project. All right, so now let's take a look into our my project right here. Now the first question is, as I mentioned, I want to be more objective about the greenhouse gas emission with the temperature, like how they correlated. So I find the global average temperature first, which is now this temperature from the 1850 to 2018. So the temperature is based on the average temperature of 1950 to 1980. Now, as you can see right here, before industrialization, the temperature is relatively low. But after 1980s, you see that the temperature is just growing higher and higher and higher, and it's like exponentially higher right here. And similarly for the greenhouse gas emission, now I couldn't find too much information before 1990, so I can only start from 1990 to 2010. Now between these 20 years, as you can see here, my greenhouse gas emission also is increasing. So both of them moving to the same direction. So I will assuming that they have the same, they have the positive correlation. So now for my case, what I do here is first of all, I find their correlation coefficient. Now the temperature with carbon dioxide, which is the highest, that's 0.77. So 0.77 is very close to 1. If we talk about correlation coefficient, when the number is closer to 1, is getting stronger and stronger positive correlated. Now 0.77 is a pretty high number. So in this case right here, we can say that they're strong positive correlated. And then the second thing here, I'm looking for the simple linear regression or the multilinear regression. So I did all of them here, and I was gonna compare AIC and AICC. And from here, now of course I find out that the lower sorry, my bad. So I think is the lower the better for the AICC right here. And then as you can see here, the first one, which is temperature with carbon dioxide, and also temperature with all of the 4 greenhouse gas emissions. The AIC is pretty close. One is negative 9.4, one is negative 9.965. And the AICC right here, now clearly the temperature of carbon dioxide is way lower than the other. So compare these two right here, then I decide to use the temperature of carbon dioxide. So now, before I find my linear regression, I also put them in the histogram. Well, I also did a histogram of residuals and then the plot of residuals. And I find that the histogram is relatively normal. And then the second plot right here is scattered. And then it's kind of like uniformly distributed. So I think that's a good indication for my model. And also, like in my model here, to verify my model, that my model is good or not, I also separate my 1990 to 2010, that's 20 years, into two sets. One is a training set is by 60%, and one is a test set by 40%. So after I running them here, as you can see the result, now the actual one for 1990 is 0.623, but my prediction is 0.537. So it's pretty close. And so that's why in this case, I did not have to make a lot of adjustment. So I can just get my linear regression equation. And then once I got that, I find y is equal to negative 1.23 plus 6.365 times 10 to the negative ax. Now the x is the carbon dioxide, or not carbon, yes, carbon dioxide emission, and the y, which is the temperature. So now in this case, we can see that now the p-value I got for my linear regression is statistically significant. It's really small. It's like 0.00004. So it's relatively, it's pretty small, and then so that's why it's also is another indicator to see that our linear regression line is pretty good. All right, so now here, this is the result I got from the linear regression is by looking at the slope. Is when 1 million gigagram of carbon dioxide more releases to the atmosphere, then the global average temperature will be expected to increase by 0.064 degree. And also that's equivalent to 0.12 degree Fahrenheit. So from here now, since I see that on my own, so I was like, oh, this is a pretty interesting. So which gave us a direction about how do we control the temperature by reducing the greenhouse gas emission, of course. But how to do that, then that probably is another topic of the project. And also it probably is for other people like engineering project to do that. But it's very interesting to see this correlation right here. And then my second topic, which is my main focus for this topic, which is I want to look at for different location, different latitude, what happened for the higher temperature impact the growth rate of agricultural output. So I separate the entire world into three sets. Now the first set, so the first set right here is the countries which are between 20 degrees north and 20 degrees south. Now, as I mentioned at the beginning of the project of this talk, we know that between 20 degrees north and 20 degrees south, and most of them are warm countries. Like in my case right here, I find a sample of 9 countries: Indonesia, Cambodia, Egypt, Madagascar, Jamaica, DR, Congo, Ethiopia, Mali. So those countries. And as we can see that those countries, if we're looking at their GDP per capita is relatively low. So most of countries right here are warm countries and the low-income countries. So as we can see right here, now I find that there are correlation between the temperature and the growth producing values for each countries as a result right here. And then I take an average of them. So now this is my hypothesis test. My null hypothesis for this is the mean of the correlation is equal to 0, which means for low-income countries, for those countries right here, the mean of correlation coefficient is 0, means the temperature, the increasing of the temperature will not affect the growth rate of the agriculture producing output. And then my HA is not equal to 0, which means they are correlated. But how they correlated is maybe positive, maybe negative. But I just say it's not equal to 0. And then surprisingly, I got a result. The T right here is equal to negative 0.0769 or around 0.08. And the p-value is relatively high. The p-value is like a 0.94. So which means this is insignificant, that statistically insignificant, which means we cannot reject the null hypothesis. Now, if we cannot reject null hypothesis, which means we cannot say that the temperature will impact the growth rate of the gross product values. And this is very interesting, because before we think that at least if there's for the warmer countries, at least the higher temperature will decrease their output, but actually it doesn't have impact. Now here is some of my assumption for, or some explanation for this part, because those warm countries, they are not, even though they want to develop their agriculture, but it's hard for them to do because of the temperature, the climate doesn't allow them to do that. So the higher the temperature, that will make their product not increasing, or maybe not decreasing that much as well, because originally is already a bad situation. So this is my explanation for those countries between 20 degrees north and 20 degrees south. And then my second category is for the countries which is above 45 degrees north and 45 degrees south. So for those countries, now more above 45 degrees south is a little bit difficult to find, because in the southern hemisphere we do not have a lot of countries. So most of the countries I have right here is for the countries who are located more than higher than 45 degrees north. And then as we can see that for those countries, those are colder countries like Russia, like Ireland. Those countries are so those countries are high GDP, but they may not heavily rely on their agriculture producing for their GDP. So for my HO right here, still going to be the mean of correlation coefficient of them is 0. And then HA, the alternative hypothesis, is not equal to 0, which means they are correlated to each other. So the countries I find right here, there are 8 countries. Now China, Canada, US, Norway, Russia, Ireland, Japan, and Argentina. And then interestingly, again, the p-value right here is equal to 0.8931. So that makes very interesting result, because before this project we mentioned about, maybe the higher latitude countries, their temperature getting higher, so they will benefit from that. But the p-value right here doesn't really say it. Now the first problem that I have probably is because I need a larger sample size. I need more countries. That's the first thing. And the second thing right here, now if you look into those countries, now for China is negative 0.4, but we need to know that China is a huge, like China, Canada, US, these 3 countries are huge countries. So part of it is hot, and the part of it, like north of it, is very cold, and the south of it is very hot. So if we're talking about the whole country, we probably cannot really talk about the whole country's situation. If we have time, we should look into those bigger countries and separate them in the regions and to see different latitude all in this country they're producing, like the situation of their producing. So this is my second explanation. Well, this is another of my explanation. And also, like as you can see right here, even though US is negative 0.06, but it's really, really close to zero. And another thing that I can explain, I try to explain this is, I think in US, we know that US is a high advanced country with technology. So even though they get an impact from the, they get some negative impact from the temperature, but the technology always going to help them. And also because they're higher GDP. So it won't affect them that much with temperature increasing, at least in the short run. I'm not sure about long run. Long run, I think probably a lot of countries going to suffer. But in the short run, US, I think the United States will be fine in this situation. But also, if we can see like Norway, Russia, Ireland, now those countries, as you can see right there, their temperature is relatively low, but their producing is actually positive. Now this is actually verified what I just said. For those countries, like really, really cold countries, when the temperature is getting higher, and their agriculture is actually getting better. So for my third category right here, that's for the countries above 20 degree north or south and below 45 degree north or south. Now again, like for those countries in this category, most of them are the agriculture producing countries. Now also I put China and Argentina and the US in this category. It's just because China, Argentina, US, they are bigger country, so some part of them producing, they have agriculture producing, and then some part maybe don't. So that's why I put China and Argentina, US, them still in this category. So now in these 6 countries right here, now as we can see right here, the p-value change, the p-value become 0.004849. And if you compare this with the first 2 categories, it makes a huge difference. Now, in my agriculture producing countries, when I do the alternative hypothesis, I make a bold assumption. I'm assuming that higher temperature will decrease their agriculture producing, and then my hypothesis testing actually verified that, which is true. So we're gonna reject the null hypothesis and accept alternative hypothesis, which means the higher temperature will decrease the agricultural output. So this is a very interesting result I got right here. Now, and also that's the reason why I called my project a nonlinear impact. So before we think that higher the temperature will decrease the agricultural output in general. So that's why we think it's a linear, but it is not. From my 3 hypothesis tests, we find that they are nonlinear impact. So which means if you think of x-axis is your temperature, and then the y-axis is your agricultural output values, or growth rate of agriculture producing values here, and you can say that for both sides, for the either really hot countries like warm countries or colder countries, they not get an impact. So their growth rate is relatively stable. But for those agriculture producing countries, their growth rates actually become decreasing when the temperature is higher. So this is a nonlinear impact for the temperature. So now, so in this case right here, and since I find this a 3 hypothesis testing, which is which is a very interesting result, and it also verified a lot of other researchers' beliefs. So the only modification I did right here is I separate countries not by their income, just by their locations. So this is this is what I did for my project. All right, and also like before we mentioned that some countries gonna win, some country gonna lose when the temperature increasing, and we still gonna say that for those colder countries, higher income countries, they're still gonna win, and who gonna lose? The agriculturing countries definitely gonna lose because their temperature affects their growth rate directly, and also is gonna make those low income countries suffer. Now the reason behind that is for those low income food deficit countries, even though the temperature doesn't impact their growth rate of agricultural output, but because they are food deficit, so they need to rely on those agricultural producing countries, the imports of the food. So when the agricultural countries producing level decreases, then that will make supply, especially when we have a more and more population, so the supply of the food will increasing. The supply of the food is gonna decreasing, but the demand of the food will increasing. So in that case, will shifting the food price increase by a lot. So if the the price of the food increase, then for those low income countries, then they probably cannot afford the food. So now here, that's the reason why I think for those lower income countries, even the temperature does not have a direct impact, but it's definitely going to have indirect impact on their daily life about the food. So for my conclusion right here is first of all, I find that greenhouse gas emission is highly correlated to the temperature. So the higher the emissions is, the higher the temperature will be. And the second thing I find is just by the locations, the higher latitude countries will possibly benefit from this temperature increasing in the short run, not in the long run, but in the short run. But for those low income food deficit countries, they're gonna suffer immediately, and also because the agricultural producing countries producing level decreases. So those are my findings. And then for my future study and future work, I would like to see the 2 points. Now the first point is the other indicators of the global warming. In this project, I only focus on the temperature increasing, decreasing, but I didn't look at the other possible indicators of the global warming, like the sea level increasing or decreasing, then that may change some industries or the amount of rain, heat waves. So there are many things, the indicators of global warming, that I didn't have a chance to look into. And I want to see that for my future work, I want to see that for those indicators, how those indicators gonna affect the economy, and how the economy gonna shifting because of that for different countries. And then my second point is I only for this project, I'm only looking at the agricultural output. I didn't really have a chance to look at other economic activities. So I would like to see that when temperature increasing, how does that gonna change like insurance industry, labor supply, or like labor productivity? So those are also gonna be an interesting project to do. I think if we can, well, global warming is just not one concept. It has a multiple dimensions. So if we can look at the more dimensions, then we can understand it better. So then we can quickly adapt to the new situation, the new temperature. We can prepare ourselves for more changes. So this is my project. Thank you very much. Thank you for listening, and good luck with everything.